Hello my friends of Watershed Labs, my name is Saul Montoya. Please welcome to this tutorial. This tutorial is for determination of the watershed and channel network on large case basins with QGIS. Okay, so the first step here is that we are going to download data for, the elevation model for our area of interest. For that, you are going to receive a folder that has this is where we are going to store the elevation models. These are the output GeoJSON or shapefile, and these are the some utilitarian shapefiles that shows or that points to our area of interest. Okay, so here I will upload the file that it will be my GeoJSON. Okay, great. Then I will select here. Okay, and my first result, but that could be my first result, but because it's not actually your first result, will be str mlg, but I can also look for that str mlg somehow, and it has to be capital str mlg1. Yeah, and this I don't understand that. Okay, so if you if I don't place anything here, okay, I will look for that. Okay, I will load my GeoJSON. Okay, and then I will call my map imagery. Okay, these datasets appear first. Okay, but actually if I type a name, actually I cannot query that dataset. This is not a problem from me, this is a problem from NASA. Okay, and then you can use this one, or you can use this other dataset, this one as well. Okay, for me it's whichever is okay. So, and there are 4 granules here. So, and the visualization, this is quite good. Okay, so I will download all of them. Okay, download data. Okay, and then I will ensure. Okay, these are from the previous tries. So here I'm going to download this one, this one, this one, and this one. So actually it's downloaded, it will be downloading 4 files. Okay, maybe one is missing, so 481 580, I think that is missing. 580, this one. No, it's not missing. Let's see, 480, 481, 580, 581. 581, this one. Okay, great. So I will extract here, extract here, extract here, and this one I will extract here. Okay, great. So this Control C, I will place here on my DEM. Okay, and these are the most important steps here on QGIS. Okay, really sorry that my QGIS in Spanish is a beautiful language. Okay, I hope that you can manage some questions, but I hope that you can get it, you can get the workflow in this. Okay, okay, so here on documents I'm going to open the 4 files. Okay, here I have the 4 files. Okay, let me do something. Okay, I did something more smart, so I have changed QGIS to English, so you are not going to hassle with the traductions. Okay, so here in home on this folder where we have placed our them files, we open them. Okay, these are the four of them, and then what we are going to do is we are going to create a virtual raster, virtual raster. Okay, so we are going to select the four thems. Okay, okay, and then we are going to place everything in one band. Okay, great. So here I have my one band. Actually, I'm not interested anymore in these ones. Why I do delete them? Because it it creates disorder on the computation, because we are dealing mostly with temporal rasters or temporal files. So sometimes the majority of the errors is because you have pulled or you have worked with a raster that was not the most suitable. Okay, so then we are going to wrap our raster. Because why? Because what I have seen is that the field sinks, the hydrological correction of one lieu works with UTM. It doesn't work with geographicals, and these ones by default, the ones that you download, comes in WGS 84. So we need to 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 come reproject. So actually this is in GEDAL raster wrap reproject wrap reproject. Okay, wrap reproject. I don't know why. I mean, this is not. If I type wrap, actually nothing comes. But if I type with capital, actually nothing comes. But if I go here, projections, here is actually wrap, warp, 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 warp. Sorry, my English is not good enough. Okay, so here is this the target will be, I will change it to UTM. Actually this is in zone 17 south in WGS 84. Okay, and then here I will here the output resolution. I can do two processing once. First I can change the projection, and then I can change the output resolution. Why do I change the output resolution? Because I'm talking about large scale basins. So in large scale basins, I'm not interested in defining the watershed network on a depth of 30 meters. Not because that is not possible, because it will take so long. So actually I will change the resolution to 120, and this will be quite an advantage to work because it takes less time, and on large scale basins the difference is minor. Okay, it will have a difference if you are working in a small scale basin. I mean, what is the difference in between a large scale and small scale? Actually not that much. Okay, so this is already in 32717, so it's in UTM. And then if we go to properties, and then here on information, we'll see that the pixel size is 120. Okay, I am going to save this one. Okay, save as. Why? Because if you see, both are output. Okay, so I don't want to, I mean, I have to be very ordered. Okay, otherwise I will have some problems. So this is will be the WGS 17 south, then WGS 17 south, and with a raster resolution of 120 meters. Okay, great. So okay, great. So I get rid of the other ones because I actually don't need it. Okay, from that I'm going to do the field sinks of one lieu. So field sinks of one lieu. Okay, and the minimum slope, I'm interested in field depth and the flow directions, but not interested in the watershed basins. Okay, you can place a background map to okay. Okay, so this is the flow direction. Okay, I can place a background map here, a Google satellite that is actually sorry, the problem is that is this one. Okay, just copy print this if you want this on your, so, and then with that you get the background map. And then what we are, something that we are looking for in this in order to see that if our geoprocess is right, is that our FDL has to be positive numbers. Okay, so what does it mean? That, okay, I will show you on the property symbology, unique values, classify, and then here in greens, and this one in red. Actually, we are not interested in finding red spots here. And why not? Because those red spots means that it's a sink. Okay, so it's actually a cell that has no flow direction. Okay, and if you have those cells, then you are not going, or you won't be able to define the string network. Okay, here actually it's all right. So I can save this as well. I can save this as well. So this is filled. Okay. Okay, so I get rid of all of them because I'm not interested in them anymore. Okay, and then what else I am going to do is that I am going to create channel network and drainage basins. Okay, so here, and this will be from the field, that is the only one. I won't be interested in flow connection, flow connectivity, not in the straddler. I will be interested in drainage basin channels, channel basins, and not interested in junctions. Okay, so it won't mean that it won't calculate them. It means that it won't save them, or it won't upload it to the canvas once it's ready. Okay, takes a little bit. Just to show you something on this is just to mention something. I did this many times, but on the, for example, in the times before, I used Saga in order to select to work with the to define the basins, but here I'm using just QGIS with the latest developments of QGIS. Okay, so here I have the basins, but those are the, how say, the Maxify basins. What I would like to know, for example, is I want to create a basins from this point. Okay, maybe a basin from this point. So this is actually possible. Okay, so and for that we need to do something that is called upslope area. Upslope area. Okay. First, I really need to be very close to the string network. Okay, and then I need to go to coordinate capture. Okay, and here on the system of projection, I have to change the project system of reference to my UTM, and here I will capture any point that is close to the string network. So it's this one. Okay, so, and why? Because if I do upslope area, I need the target X, so it will be the X of this point. the tangent y, it will be the y of this point. The elevation, what will be our them. Nothing else, and then run. And then the method, any of them. I mean, I have no particular choice for any method. I don't have a particular choice for any method. Okay, let's wait a little bit. Okay, and then you will see that the output basin will be plotted, but as it will be plotted as it will be plotted as uh, as a raster. So what else we need to do is polygonize, and then what the area. Okay, run. Okay, great. And then here, well, there are many small polygons here. Actually, I'm interested in this one. Okay, and then here on output, I have to export, save feature as only selected features as GeoJSON, and then here on out, this will be called basin. Okay, and the next thing that you might be interested is on the river networks. Okay, no, channel network. Okay, so this is the channel network. Actually, the colors are not so pretty. Okay, so there is a way where we can use the flow accumulation or the drainage area in order to define the water network. Okay, but I haven't been successful in doing that. Okay, for doing this it took me a time, so I think the process so far is okay, but I will work on something for the to define this with a certain threshold on flow accumulation. Okay, so here on segments I will do clip. Entonces clip on vector overlay, I will clip the segments by basins. Let's see if this works. And here I have clipped. No. Wait. Okay. I will get rid of this because actually it's not. Okay. So these are the clip, and the clip have not clipped anything. Okay. So this one is not. Okay, so here I have segments, and here I have my base. Clip. A ver. Segments should be clipped by basin. Okay, I don't know why, but it worked this way. Okay, maybe that's why it's important to be ordered. Okay, so this is the clipped version of my. Okay, so now what you can have is the watershed and the drainage and the channel network of a large-scale basin procedure in QGIS. Why is large-scale basin? Because this is actually 100 kilometers. Okay, for me it's large. Okay, So really thank you for this. Really thank you for your patience. Um, Hope that this tutorial will be helpful for you. It's kind of a basic procedure, but it's basic not because it's easy, it's basic because it's fundamental on the work that we do with water resources. Okay, my name is Sol Montoya. You will find some of the step rasters and the area of interest in on the description of the video. I strongly recommend that you follow this video and then you do by your own, because uh, like the probabilities of failure if you do it on your own area of study are much bigger than if you do first on the tutorial and then on your own. My name is Saul Montoya from Qatari Labs. Please follow our YouTube channel, sign up for our online course, follow our blog, and share with your friends. Okay, have a nice day. Bye bye.